This video, we're going to look at the last type of special series, which is a telescoping series. So we've already looked at this example here. We did this all the way back at the beginning of this chapter, where we were looking at, does the series actually converge or not? And we found that this actually converges. Okay? But now we can actually give this type of series a name. It's a telescoping series. And the reason why it's telescoping is the fact that whenever we have a telescoping series, these are types of series in which most of the terms cancel in each of the partial sums, leaving only some of the first terms and some of the last terms. All right, and the reason why we call it like a telescoping series is we think of this series as it like collapse within itself, like one of those old telescopes. Let's see what we have here. Let's see if I can show you what I'm talking about. So when I'm referring to a collapsing telescope, it's like one of these things right here, where you can, like, I don't know, put it in a backpack and then you can pull it out and it gets real long and you can see long distances and collapse it in of itself. That's what we mean by a telescoping series. So what does this actually look like? Well, given the series that we worked with earlier, let's see what happens with this. So if I were to use partial fraction decomposition here, all right, what you end up getting is the following. 1 over n times a quantity n plus 1, its partial fraction decomposition is 1 over n minus 1 over n plus 1. Therefore, I can rewrite my series as such. Okay? Now, if I were to write out some of these partial sums here, I end up getting this. All right, and it just keeps on going. Now, one of the things here you're going to notice is I have negative 1/2 and then positive 1/2. Then I have negative 1/3 and positive 1/3 and so forth. This is going to keep going. So this is what we mean by a telescoping sequence. It's going to, when we start adding up all these partial sums, like our first partial sum is 1 minus 1/2. Our second partial sum is going to be this. Notice that the 1/2s, they just cancel themselves out. So you're left with the first term and then the last term. And this is going to keep on progressing forever and ever and ever. So we'll write out the third partial sum here. So in general, what ends up happening here is that we're going to end up with all these terms that cancel themselves out. So let me write out what this looks like. So we have 1 minus 1/2 plus the quantity 1/2 minus 1/3 plus the quantity 1/3 minus 1/4. So this is S1, S2, S3 respectively. And this is going to keep going until we end up with this. So 1 minus 1 over k plus 1. Now for this series, since Sk is equal to 1 minus 1 over k plus 1 and 1 over k plus 1 goes to 0 as k goes to infinity, the sequence of the partial sums will converge to 1, which is what we demonstrated earlier. So this is what we mean by a telescoping series. All these terms, all in the middle here, they just end up canceling. So you're left over with 1 minus 1 over k plus 1. That's a beautiful thing when that happens. So let's look at an example that we haven't seen yet. So determine if the summation of n equals 1 to infinity of the cosine of 1 over n minus the cosine of 1 over n plus 1 converges or diverges. All right, so the first thing we're going to do, we're going to start writing out some partial sums. Every single one of these, you need to start writing out partial sums. So we get the cosine of 1 minus the cosine of 1/2. That's our first partial sum. Second partial sum is going to be the cosine of 1 minus the cosine of 1/2 plus the cosine of 1/2 minus the cosine of 1/3, which turns out to be the cosine of 1 minus the cosine of 1/3, because those two cancel. So it's looking pretty good. Let's do another one. I have to write really small here for this. So our third partial sum is going to be the cosine of 1 minus the cosine of 1/2. That's S1 plus the cosine of 1/2 minus the cosine of 1/3. That's S2 plus the cosine of 1/3 minus the cosine of 1/4. That's S3. And we can see, we know these cancel. And when we add, these are going to cancel. So this is just going to equal the cosine of 1 minus the cosine of 1/4. Which means, in general, Sk is going to equal the cosine of 1 minus the cosine of 1 over k plus 1. So this is a telescoping series. Now the question becomes, where does this converge to? All right, that's the biggie. So we need to go back to our definition and understand what's happening. Since 1 over k plus 1 goes to 0, as k goes to infinity, And cosine of x is a continuous function. Cosine of 1 over k plus 1 goes to the cosine of 0, which is equal to 1. Therefore, sk is going to go to the cosine of 1 minus 1 for our convergence. Thus, I'm going to use these 3 dots here, make it look real nice. Thus, the series from n equals 1 to infinity of cosine of 1 over n minus the cosine of 1 over n plus 1 converges to the cosine of 1 minus 1, whatever that turns out to be. And that's going to be it for this section. It's a doozy, but I know you can do it, so good luck.